All right, this is a flow problem. Schematically, we have a 600-gallon tank here. We have water flowing in at 4 gallons per minute, and the concentration is a ½ pound per gallon, and the flow out rate is also 4 gallons per minute. So we want to set up a differential equation and find out how much salt is in after t minutes. And we're given it starts with 4. So, well, first we want to look at the rate in. The rate salt is coming in is going to be the 4 gallons per minute. And then we have 0.5 or a ½ pound per gallon, which gives us that the rate in is a half of 4 is 2 pounds per minute. All right, now the concentration of salt in the tank is concentration, well, that is amount over volume, and that is going to be Q Q over, in this case the volume stays a steady 600, right? And so the rate out is going to be the concentration, which, well, first let's do the flow rate. That's also 4 gallons per minute, just as before. But this time the concentration is Q over 600 pounds per gallon, which gives us, let's see, 4 goes into 600, 150 times. So this is just Q over 150. So the differential equation we want to work with is dq dt, total rate of change, is rate in minus rate out, and that is, what did we decide that was? 2 minus, and then Q over 150. This is a first order linear equation, so let's write it as Q prime plus Q over 150 equals 2. So the integrating factor is e to the integral dt over 150 is just e to the t over 150. At this point, you've probably done enough of these constant coefficient ones, you just could have guessed that. So this is now e to the t 150 q, the whole thing prime, is 2 e to the t over 150, integrating e t 150 q is 2 integral e to the t dt. So that's going to be 2 times 150 e to the t to the 150 plus a constant of integration. And we can just check that. If I take the derivative here, the chain rule, the 150s are going to cancel out. So now multiplying by the reciprocal of this, or e to the negative t over 150, gives us q is 2 times 150, the exponentials cancel, plus c e to the minus t over 150, or q of t equals 300 plus c e to the minus t over 150. And to get the constant, we're going to u is 300 plus c times e to the 0, which is just 1, is 40. So c is going to be 40 minus 300 is minus 260, I guess. So our final formula is q of t equals 300 minus 260 e to the minus t over 150. The second part of the problem asks us to find limit as t gets big of q of t. Well, we can just see that from here that this is 300 minus 260 times e to the minus a big number, and e to a big negative power is essentially 0, so this is going to be 300. Or we could be fancier about it. Our original equation is q prime equals, let's see, where was it? 2 minus q over 150. This is an autonomous equation, so we can analyze it without having to solve it if we wanted to. So to get the constant solutions, or the critical solutions, we're going to solve q prime is 2 minus q over 150 equals 0, which gives q equals 2 times 150 equals 300. And if we draw how that looks, if we go with 300, and if we're above 300, this term's going to dominate and it's going to be negative. So if we're above 300, things are decreasing. Below 300, they're increasing, so solutions look like this. So from this we can see, since 300 is a horizontal asymptote, this would give us, at least to me, a somewhat more convincing argument that q of as t goes to infinity equals 300. And we're done.